Hello students, welcome once again. So today we are going to discuss the practice questions, the questions which I gave you people to the advanced level. So let's start. The first question in the list is this one. Just a minute. Yeah, the question is it's x squared minus x minus 1 upon x plus 1. See, that's not a difficult question, of course. Okay, those students who would have attempted this, solved this question must be knowing that's not a difficult question, but sometimes you'll find in advanced paper that the format of the question is such that several students will leave the question just after reading it. Why so? It seems to be quite complex. Okay, now let's try to solve this. See, the first thing that should strike our mind is to, of course, can we simplify it further? See, you look at this expression. Can't we write it as 1 upon 1 plus x square? And that's a very common form when we come to substituting some expression by t and then looking for its derivative. Do you understand what I'm trying to say here? We have already seen in our JEE mains level that practice session that where we got something like x plus 1 by x and looking for its derivative, or x minus 1 by x and looking for its derivative. I believe that you all must be remembering that form. Okay, so this is derivative of x minus 1 by x. Okay, so now try to rewrite this and simplify it. So what will we get here? We will get x and then it's minus 1 and then it's minus 1 by x, and we are done, bacho. And that's the power x plus 7 into x rather 1 plus 1 by x square, and that's it, integral. So what is it? So this these terms are gone. So if I replace, let x minus 1 by x be t. Its derivative is 1 plus 1 by x square dx is dt. Fine. So therefore integral. No, I think that's a done deal. T raised power k plus 7 and dt. That's it. So that's really a simple question. The only reason why I picked up this question for advanced level discussion is thus its format, the outlook of this question. Okay, so that was the only reason. So now moving to the second question here. Second question is integral of tan theta over tan square theta plus tan theta plus 1 d theta. Okay, see, again the first thing that struck my mind looking at this question was, let us replace tan theta by t. Now beauty of this derivative of tan theta is we have sec square theta, which we can again express right in terms of tan theta. So I can replace d theta as dt by sec square theta, and sec square theta we all know is 1 plus tan square theta, and tan theta is t, so 1 plus t square. So that will help us to write this integrand in terms of t completely. So t dt over 1 plus t square into 1 plus t square plus t. Okay, now one thing which you can do is you can go for partial fraction. Okay, you have two like factors, though quadratic factors in the denominator. Acha, one thing if you observe here, bacho, see, that's what I always suggest, like when you are going for partial fraction and if the coefficient of highest degree term in both the factors, and you have two factors in denominator, of course you need at least two factors in denominator to go for partial fraction method. Okay, so if the highest degree terms coefficient in both the factors is same, then try to write that form, the partial fraction form, directly as difference or sum of those two factors. Okay, so what am I trying to say here is, if I wish, we can try to write it as t square plus 1, this expression 1 plus t square plus t, as, see, just try it, 1 plus t square minus 1 upon, so I'm just balancing it. Then we will check that do we get the same thing what we have in LHS. Of course we will get it. When you take LCM, here it will be 1 plus t square plus t minus 1 minus t square. So 1 and t square gets cancelled and you're left with t here, and that's what you have in numerator. So that's it. So sometimes if you are like alert enough and we know these small like tricks while like solving the question, it might be really very helpful and it will save your time. Okay, now I think that's a done deal, because then integral is 1 upon 1 plus t square, we all know what is it, and then we will express it to a perfect square form, and that is 1 plus half whole square plus root 3 by 2 whole square. So again it is dx upon x square plus a square. So in both the cases we get tan inverse function. So this is directly tan inverse of t, and here also you will get it in terms of tan inverse, and that's it. So that was second question. Moving to the third question here. So third one is dx upon, see again, cos cube minus sine cube. Now we have two options, either express cos cube and sine cube in terms of 3 theta, 3x, but then normally we do it when we have cubic term in numerator, okay, not in denominator, but because in that case you will get 4 terms, 2 for cos cube and 2 for sine cube, bacho. So I personally won't suggest it, neither did I try that. Okay, how did I start? I started by like factorizing it as a cube minus b cube, which is a minus b into a square plus b square plus ab. A square plus b square is this, and ab is of course you know sin x into cos x. Now see, then I just try to express this, of course multiply and divide by 2, so you get it. So this is 2 times, okay, dx upon, fine. Now see, we know that we can express sine 2x, this is nothing but sine 2x, so if you wish we can write it here. Okay, there's a power cut, I am continuing, maybe we may have power back in few minutes. Okay, so I'm just continuing, at least board is visible, that's what I know, bacho. Okay, so sin x minus cos x into 2 plus sine 2x. Okay, there's a music being played somewhere. Okay, it's fine. Okay, now see, that's it. Now see, we know that we can express sine 2x in terms of both cos x minus sin x and cos x plus sin x, bacho. Okay, so sine 2x can be written as cos x plus sin x whole square minus 1, or we can write it as 1 minus cos x minus sin x whole square. Isn't that? Okay, now which one to use is the question. So shouldn't we go for like cos x minus sin x, because in that case we have cos x plus sin x in the as a like derivative, or we can go for cos x plus sin x and we have its derivative as cos x minus sin x here. Okay, so now which one to use, that we can easily decide here, but I think there's a power problem here. Yeah, we are back. We are back. Fine, fine. Okay, now see, just a minute. Right. See, so which one shall we use? Shall we go for, right? Let's go for cos x plus sin x. Why? See, so I will replace this here. So therefore, our integral is dx upon cos x minus sin x into, and this is 2 plus sine 2x. I am replacing, you will come to know why am I doing it, bacho. Okay, so 2 minus 1 is 1 plus sine x plus cos x whole square. Fine. Now why am I doing it? Because if I replace sine x plus cos x by t, its derivative is cos x minus sine x dx is dt. See, we have just dx in the numerator. See, so therefore if I try to replace it in terms of t here, what are we going to get? We will get dt upon cos x minus sin x whole square. I think all of you will agree here. And then we have 1 plus t square. Now again see, I'm going to open it again. So what will we get here? So it's dt upon cos square plus sin square is 1. And then again we got minus sine 2x, 2 sin x cos x minus sine 2x, and then since we have substituted t as sin x plus cos x, so I will again express it as, so minus sine 2x and then sine 2x again as cos x plus sin x whole square minus 1 plus 1. That's it, bacho. And then we have 1 plus t square. So now that's the form which you can easily integrate, isn't that? So it's dt upon, if I am not wrong, it's 1 plus t square, right? And then it's 2 minus t square. So it's 1 plus t square into 2 minus t square. And then see, it's a direct partial derivative form. Again, see, again I will say that, again, in both the factors, both are quadratic factor, leading coefficient, magnitude wise at least it's same. Okay, so if I have to do it again, I won't try that formal method of partial fraction, I will try to do it directly. Okay, so 2 minus t square and then 1 upon 1 plus t square. Now here if you add t square term will get cancelled, but you will get 3 in the numerator, whereas you have 1 only in the numerator, so divide by 3, that's it. So you can easily write it as 1 by 3 times, if we go for its integral, so 1 by 3 times dt, just a minute, dt, so 1 by 3 times dt upon 2 minus t square plus 1 by 3 times dt over 1 plus t square, that's it. And then we have the standard form, the standard result, and we can do it easily. So chaliye, moving to the fourth question. The fourth question is e raised to the power x times x cube into x plus 2 plus 8 upon x plus 2 whole square. Okay. Right, see, I tried it. I got this question and I tried it. It was an interesting question, because what I found here was, if you just go on simplifying whatever you have within bracket, just go on simplifying it. So what do you get? You get x cube upon this is x plus 2 plus 8 upon x plus 2 whole square. Okay, then I moved further and wrote it as x into x plus 2, rather x square, balancing it, okay, or you can say dividing numerator by denominator, upon x plus 2, so minus 2x square upon x plus 2 plus 8 upon x plus 2 whole square. Isn't that bacho? Now at last again, so moving further, e raised power x into, so that's gone. We are left with that one, so x square minus 2x into x plus 2 upon x plus 2 plus 8 upon x plus 2 whole square. See, you subtracted 4x, we have to add 4x upon x plus 2. Okay? Now at last we have, so for further simplifying it, so one integral is this, which we can solve with the help of course by parts. And then this is gone, and the integral is minus 2 times x e raised power x dx, that's also sorted, I believe. Okay, now again here for this one, e raised power x 4 into x plus 2 upon x plus 2 minus 8 upon x plus 2, and this term gets sorry won't get cancelled. This is plus 2 square, but in that case we can use there the by parts result, e raised power x into fx plus f dash x is integral is e raised power x into fx. If this is the function, this is its derivative. Okay, so this we all can do with the help of by parts. Bacho, I think you all can do this. We can do with the help of by parts. This is already done, and for the last thing we have I1, I2. If I take it common, minus 8 e raised power x 1 upon x plus 2 minus 1 upon x plus 2 whole square. That's it. Okay, so that was a question where I found that if we just go on simplifying it, we can apply by parts very easily to solve this question. So that was the fourth one. Moving to the fifth one, fx be a polynomial of degree 3 such that, see, it's a third degree polynomial. So if I normally this is how we start, just by reading that much portion of the question. We are given f of 0 is 1, f of 1 is 2. If 0 is a critical point which is not a local extrema, what does that mean? Critical point, that means f dash is 0, f dash 0 is 0, that means x is equal to 0 is a root of f dash x is equal to 0, isn't that? But it's not a critical point. And see, it's a like third degree polynomial, its derivative will be a second degree polynomial. Second degree polynomial whose one root is x, whose one factor is x, because one root is 0. second degree polynomial, but it's not a local maximum. And see, when does the critical point won't be a local maxima or local minima, it won't be a local maximum or local minima when the sign change about its factor, about that root 0 is not there. If there's a sign change about the critical point of first order derivative, that point will definitely be either of local maxima or local minima. Okay, since it's not a local maxima, local minima, so this does not have a sign change about x is equal to 0, and x is equal to 0 is a root of this f dash x equal to 0. Now what does it, and moreover we know that degree of this polynomial is 2, so that means f dash x is nothing but ax square. I believe all of you will agree with this statement. Again I am repeating, fx is a third degree polynomial, f dash x has to be a 2 degree polynomial, and since it has the root as 0 whose factor should have an even power, why? Because then only there won't be any sign change of f dash x about x is equal to 0. That's it. Okay, so now if we just integrate it, so we get fx as ax cube by 3 plus b. Just put the value, bacho. F of 0 is 1, so that means b is 1. Okay, and then we have one more thing, f of 1 is 2. Just a minute. F of 1 is 2. So f of 1 is 2 means this is 2 by 3 plus 1. So 2 f of 1 is 2. Okay, a by 3. I'm sorry. So a is 3, right? So that means, okay, so fx is x cube plus 1. That's it. Fine, bacho? Okay, so x cube plus 1. So then only it gets f of 1 is 2, right? Now, okay, fx upon under root of x square plus 7. So now we have to just integrate this. So fx upon square root of x square plus 7. So how? So again, see, I will just try to reduce it. So x into x square plus 7 upon under root of x square plus 7. So I added 7x, I need to subtract 7x. So x upon under root of x square plus 7. Now this one is done. How so? X square plus 7bt, its derivative is sitting here. So you can write it as 7 by 2 dt upon root t, and then it's done. But what about here? So here you will get it in the form. So this is x under root of x square plus 7. Now again, in this one also, what you can do is, see, you can try to solve it using linear into under root of quadratic. But here what you can easily do is, you can just replace x square by 7 by z square. So its derivative x dx will be z dz. Now just put the value. So x dx is gone. Okay, this is z, and then it's z square dz. If I am not wrong, not committing any mistake, that will be the form, and then of course we know how to do it. Okay, so that was this question. I found it to be an interesting question because of involvement of some concept of application of derivative also. Okay, so now moving to the next one. Next question is, if I is this, we have to just integrate it, isn't that? X square plus 1 upon x square minus 1. Fine. See, one thing is very clear. If I replace x square by t, so I is half dt and t plus 1 upon t minus 1. Isn't that, bacho? Of course, yes. Then what else? So now what I will try here is, let's replace t minus 1 by z square. So dt is 2z dz. I think we are done, because then we will replace t by 1 plus z square, isn't that? So it's I is equal to, so 2z, 2 gone, z gone, okay, z dz under root of 2 plus z square upon z. That's it, and that's it. So again, that's a standard form, bacho. Okay, I see those 6, if you remember it, I've been again and again mentioning this thing, under root of x square plus a square under root of a square minus x square under root of x square minus a square. These three in numerator. Similarly, these three in the denominator. 1 upon the root of a square plus a square, 1 upon under root of x square minus a square, 1 upon the root of x square minus a square, whatever. So these 6 forms are extremely important. You should know their result by heart. Okay, so you shouldn't have to think while writing its final form, final integral. Now the values of a and b for which this, so the integral is 2 sine 2x minus cos x upon 4 minus cos square x minus 4 sin x dx. So we have to just integrate it. The first thing is that I can see here is I can take cos common from numerator, because I will write sine 2x as 2 sin x cos x, and then you have cos x common, so it's 4 sin x minus 1 upon, and then I will write this cos square x as c. I think you all must be understanding in which direction am I heading here. So I am heading to the direction where I will be replacing sin x by t and then get everything in terms of t, because in that case cos x dx will be dt bachcho. Okay, so for that case I need to rewrite cos square x in terms of sin square x. What will that be? So it will be sin square x minus 4 sin x and then minus 1 plus 3, yeah, isn't that? So but that's done. So what do we get here? If I replace cos x rather sin x by t, cos x dx will be dt. So the integral is integral of 4t minus 1 upon its t square minus 4t plus c. Now you all can easily solve it. It's linear upon quadratic form. Okay, you can write it in the form of its derivative to balance it, and whatever is left, then you will be having completing the square in denominator, and then you have that form. Or shall I do it? I think we have already done it, isn't that bachcho? So if you wish, then we can try to like simplify it. So as I said, try to rewrite it as a derivative. So its derivative is 2t minus 4. Derivative of denominator is 2t minus 4. So take 2 common, so it's 2t minus 4. Fine. Upon t square minus 4t plus 3. So actually what happened? 4t was already there, 4t is there, minus 8. We had only minus 1. So that means I subtracted 7, so add 7, plus 7, and that's it. Now denominator as a perfect square. That's it, isn't that? We are done. So that's a standard form, and now this is dt upon dt dz upon, if I replace it with z, so its derivative is the numerator, so dz by z, which is ln of z. So now you can easily do it. So moving to the next one. Next one here is integral of g of x into 1 plus x ln x minus 5 upon x ln x raised to the power 6 is equal to g of x upon ln x raised to the power 5 plus c. We have to find the gx, the nth derivative of gx, and then we have to find gx. See how we can do it? Just differentiating both the sides, because we don't know anything about g of x. Okay, so just differentiate both the sides. What will we get? So in of course in LHS that integral term will be gone. So 1 plus x into ln x upon x into ln x raised to the power 6 minus 5 times g of x upon ln x raised to the power 6 upon x. Okay, I mean that's the integrand. So you'll get the integrand as it. Now we have to apply here differentiation using quotient rule. So it says it will be rather instead of using quotient rule, let's apply product rule. Okay, so if I differentiate the what shall we do? Yeah, if I differentiate the denominator first, so keeping numerator out of it, denominator derivative is minus 5x upon ln x raised to the power 6 into 1 by x using chain rule. Derivative of 1 upon ln x raised to the power 5. Okay, using chain rule. And then differentiating the numerator, so g dash x upon ln x raised to the power 5. Okay, so let's see what do we get. That's gone. Great. This term is gone. So now you have simply, and then ln, okay, ln x 5 is also gone. So what are we left with? We are left with g of x into 1 plus x upon x is equal to g dash x, and that's it. So dy by dx, so dy by dx, if g of x I replace it with y times 1 plus x upon x. Okay, so it's dy by y is equal to 1 plus 1 by x dx, and now just integrate both the sides. You have g of x. Once you have the function g of x, you have its derivative. Whichever order derivative is required, you all can do it. We all can do it. Okay, now that's again one question. So I wish you people should do it or would have done it before, of course, looking at the solution or before I solve it. Why? Because again, see, observe one thing. So the sum of the power. So if I write here, because that's the first thing which I observed, and moreover, if you consider x square as t, its derivative is sitting in the numerator. Okay, so I will replace x square by t and then replacing x dx by half dt. Isn't that the So I write it as half times, first of all, half times dt upon, now look at the power here, it's 1 plus root is 2012th root of this expression, so 1 plus t raised to the power 1012 upon 2012 into 1 2 plus t raised to the power 3012 upon 2012. See, we have already done such a question, and at that time also in JEE mains, our JEE mains exercise practice session, we did that question. That time also I said that this year itself they have asked the question. That doesn't mean I am repeating it again and again because they have asked it this year. No, we have like discussed it here in our campus before the examination also, and then also I said that it's a very important form. Okay, so that's a repetition of that sort once we know it, and because the sum of the power is 2, and now I am not going to do it further because we all know how to do it. Sum of the power, these two add up, it's 2. Okay, so it will be you will say that again and again. I am saying I won't do it and then moving ahead. Okay, so this is the form, this is the last step I am doing, Paka. Okay, so 1012 by 2012, and then you have 2 plus 3 whole square. Now you replace this term by z, its derivative will be something constant dt by this thing, and that's it. Okay, so dz upon constant is something else that you will take care. Dz upon z is for 1012 by 2012, and then there's a simple algebraic form which we can easily integrate. Okay, so now moving to the next question, the 10th question here, and again, see, that's again a repetition, and deliberately this one also deliberately I did it because again it's a very important question, bacho, and I will say we know how to do it. Again I will say that I'm not going to complete it, we all know how to do it. Once I just give you a hint, and the hint is we'll be using by parts here. Okay, so if you use by parts here, and of course the first function in both are trigonometry, so how are we going to decide which one is first, which one is second? The simple basis, rather I always say the most important reason of having that list of IIT, that precedence order, which one is to be the first, which one is to be the second, the most important factor which is decisive, which decides which one to be first, which one to be second, is the easier one to be integrated, or the easily integrable function has to be the second function. That's the normal rule which we follow. Okay, so out of these two, of course this is directly integrable, whose integral is tan x, so that's our second function, and in that case 1 upon this thing is going to be our first function. Now you apply by parts, what will happen, that the second term will get cancelled and the first term of by parts will give us the answer. Okay, we have two parts of the integral when we apply by parts. So second part is an integral itself that will get cancelled with this one, first part will give you the answer. So I'm moving to the next question, which is 11th one here, which is yeah, very important, 5 plus 4 cos x whole square. It's a very special case, that's what I always say. See, in that case what I prefer here is, rather what I say how to approach it is, see, let us assume this thing, forget about the square term in the denominator, just consider the linear term, and then reverse the coefficient and replace cos x by its derivative. So it's 4 plus 5 sin x. Did you understand what I said? I said don't consider the square of denominator, just consider the linear term in the denominator. Whatever linear term you have, just consider it as a linear term, and then in the numerator interchange the position of these two like coefficients 5 and 4, and instead of cos x write its derivative sin x. Now you may say that the derivative of sin cos is minus sin, of course, so that also you can try. Okay, let's try which one is easier, so you will come to know here itself. Okay, so that's the normal thing, and that's a very special assumption. Now differentiating both the side, of course, so dp by dx, so what do we get? We get 5 plus 4 cos x whole square. Okay, and then of course using quotient rule, 5 plus 4 cos x into the derivative, and its derivative is 5 cos x, isn't that? And then minus numerator 4 plus 5 sin x, and derivative of denominator, which will be minus 4 sin x. Right, now let's see what do we get. So dp by dx is, so it's 25 cos x, so it's 25 cos x plus 16 sin x, and then we have 20 cos square plus 20 sin square, and that's one thing, to 20. Okay, now upon the 5 plus 4 cos x whole square, so I am breaking it into 3 different terms, bachcho. Why? I will tell you. And then this is 5 plus 4 cos x, so I don't think there was any problem in assuming it without the proper sign. Okay, so let me just check. If we replace it with minus 5, like minus 5 sin x, so it will be minus here, and then it will be minus here, so that will make it positive. But no other change. I mean, there will be a slight change in the sign, maybe. No, nothing else. Nothing will change. Okay, the form will remain same. Now let's move back. See, we have to integrate. Don't forget that we have to integrate this. So integrating both the sides, we need its integral. So this is 20 times I is equal to, now see, its integral is what? So its integral is p, isn't that? So it's p minus integral 25 cos x, 25 cos x upon 5 plus 4 cos x, if I am not wrong, whole square dx, and then minus 16 sin x. See, this one is of course the simpler one. Why so? Because if I assume or replace cos x by t, its derivative is sitting here, so it will be 16 dt upon 5 plus 4 t whole square, and we know its integral, direct, done. Now again, the last thing left out is here. So how can you take care of it? So I will write cos x upon 5 plus 4 cos x, okay, whole square. See, try to write it in terms of the denominator itself. So how? 4 and 1 by 4, okay, add 5 and then subtract 5. Bachcho, okay? Now this is gone. Now this is integral of 1 upon 5 plus 4 cos x, and this is what? This is minus 5 by 4 I. This will come this side, so 20 plus 5 by 4 I is equal to, this one is done first. Okay, this is p itself, so p we know what is it, so it's 4 plus 5 sin x upon 5 plus 4 cos x. This one is done, this one is done. So if I'm not wrong, minus 16 by 4, it is 4 times 5 plus 4 cos x, that's okay. Last one is left is this one, so I'm writing plus 1 by 4 times integral of dx upon, now how to do it? Now that's a very standard form. When you have linear term of cos and sine in denominator, you express it in terms of the twice angle result of cos, or sine in terms of tan. So I will be replacing, like I am doing it quickly here, 5 plus 4 times, what I said, rewrite using cos to theta formula in terms of tan. Now when you take its like LCM here, and then you get a quadratic in tan x by 2, and its derivative sec square x by 2. dx, and that's it. Isn't that? You will replace tan x by 2 by some variable p or z, and then dz upon quadratic z is done. Okay, so it's a very lengthy one. Of course, you can say it's a very lengthy one, but then it's a special one. That's why deliberately I selected this question so as to discuss it at least once with you people. So that was the purpose of selecting this a special form. Okay, very special form. Now moving to the next one. So what is it? So it's dx upon, there's lot of noise today, I don't know why. The campus, maybe students are free, I mean they must be having some party or etc. I don't know, there's a lot of them, but bear with me for some time. Okay, so now that's it. So what shall we do? Take x square common upon x raised to power 5. This is 1 plus a square upon x square. Now what? If I replace 1 plus a square by x square by t, then it's minus 2a square x cube dx by dt. I will write it as x cube into 1 by x square. Dx by x cube you have here. What is it? So it's minus dt, so it's di is equal to minus 1 by 2a square dt, bacho. And then it is under root of t, because I assumed it as t, and then see 1 by x square from here, so it's t minus 1. Okay, so it's t minus 1 by a square. That's it. Now it's done. T by root t is root t, and 1 by root t, integral done. So that's it. So now moving to the 13th question. Okay, so what is it? X square plus 20. Okay, yeah, I solved it earlier, 2-3 days back only. I solved this question. See, how did I start it? Let me just think. Yeah, I started by just thinking its derivative. So its derivative, if we look at its derivative of the term in denominator, its derivative is x cos x. Okay, and then plus sin x minus 5 sin x, so minus 4 sin x. Okay, x cos x minus 4 sin x. Let me, okay, try it again. So then I try to write x squared in terms of this term. How? So I wrote x into, we need x cos x, so I multiplied and divided by cos x. So cos x into x sin x plus 5 cos x whole square. Okay, so cos x, x cos x. Okay, so it's x square cos x and cos x gone, so it's still balanced. Okay, now whatever I added, so I need to have minus 4 sin x, so I tried to have minus 4 sin x. To balance it, I will be writing it is as 4x sin x upon cos x into x sin x plus 5 cos x whole square. ठीक है बच्चों? Fine. Now of course see, this is derivative of this. I will be applying by parts. So let's apply by parts here. So this is our first function, and this complete thing is our second function. Okay, so it's x upon cos x, first function, into dz, its derivative is sitting in numerator, so dz upon z square, so minus 1 upon x sin x plus 5 cos x. I think that done. Plus, okay, why plus? Because minus, and this minus will balance it. Now derivative of x upon cos x is cos square x into that's the integral which we get, x sin x plus 5 cos x. I am writing it directly here, bachcho. Fine. Now the numerator part, because of the differentiation of first function. Okay, so this is cos x into derivative of x is 1 minus x, and derivative is sin x, right, dx. Okay, so we have x sin x plus 5 cos x. Okay, so right, and then we have one more term which is 4x sin x upon cos x into x sin x plus 5 cos x whole square. Right, just a minute. 4x sin x. Shall we try to balance it here also? Let me do it. Wait, bacho. So 5 cos x. So if I add 4 cos x here, okay, if I add 4 cos x here, I'll be subtracting 4 cos x here. Okay? So again, so this one is done. So this is plus x sin x upon 5 cos x cancelled, integral of secant square x done. Okay? Dx, which is 10x, we know, minus 4 upon cos x into x sin x plus 5 cos x. Isn't that, bacho? Now we are left with, we have to deal with these two terms. Okay? Now if we try to bring them together, so if I take LCM, so x sin x plus 5 cos x will get multiplied here. So it will be 4x sin x minus 4x sin x gone, and then (20) minus 20 cos x. Okay, let's do it. I think we got it. Wait. So taking LCM. So I is this term plus tan x. Which term is it? This term, okay, plus tan x. Now take LCM, bacho. Integral. So it's cos x into x sin x plus 5 cos x whole square. Fine. So again, so it's 4x sin x as it is, 4x sin x as it is, minus, I think it's 4, just 4, okay, minus 4x sin x minus 20 cos x dx. That's gone. Okay, I think we are done. Minus 20, and here we had plus 20, right? Plus 20 minus 20, that's gone. Done. So that's the answer. Okay, so this plus tan x is the answer. That's it. So that was again an interesting question. Okay, moving to the last one. See, we just discussed this thing in the last session also, that there's a special form here. Okay, so I just selected one question based on that form, and the form is e raised power gx integral of gx into derivative of some function fx at plus f of x, the same function. If that's the integral, its answer is e raised power gx into f of x plus c. Okay, so here gx is sin x for sure, so that's our g of x. Now we have to rewrite it. So the integral is, e raised to the power sin x. So if I rewrite it, so of course it will be x cos x minus sin x upon cos square x. Okay, so rewriting again further we can simplify it. How? So it's tan x into secant x. Now, interesting observation is that this is derivative of secant x. This is derivative of secant x, okay. And in the form, the derivative of secant x. Right, but this has to be here. Acha, one more thing. So, see, here I will say I got a bit stuck here. In case you're solving an indefinite integral, okay, while after reading the question before proceeding in exam, I don't do it. I do it when I get stuck and I don't like any idea don't strike me, okay, because I'm not going to take any examination, so I'm not in a hurry to solve the question. But that's a session for you people. So during examination, just read the indefinite integral and you have an option as integrals, like answer in the form of integral. Go through the options. That may give you a hint. See, looking at the option, we realize that secant x. So either that, see, look at the form. fx has to be 1 plus secant x minus sec x, x plus sec x, whatever it is. Okay, now that gives the idea. How? See, if I go for its derivative, what is it? 1 minus sec x cos x. Okay, sec x tan x. That's the derivative. Okay, and that's this form here. So if I take it x minus secant x, isn't that? So gx is cos x. Okay. So see, I will write. Then what I did, I just manipulated it. Okay. So x minus sec x Okay, I'm sorry. Oh, that's why. I'm sorry. It has to be g dash x, fx, and f dash x. I'm sorry, bacho. Really sorry. Shouldn't have happened. G dash x into fx, right? F dash x. Okay. Fine. I'm sorry. Okay. So g dash x is cos x. So okay, that's what I did. So for cos x, now see what happened. X cos x was already there. Minus sec x into cos x is 1. So I subtracted 1. I will add 1. And now you have it. Isn't that? We have it because now, of course, this is our f of x. And that's its derivative. Okay, so the answer is e raised to the power, whatever it is, gx into f of x, x minus sec x. So again, see, you may say that after looking the option, you got it, of course, because as I said, I was not see that is clear. I was pretty much sure we will get it in this form, but somehow it didn't strike me. Okay, so I just tried to look at the option, and then the moment I saw it, it's stuck. So that's what I will suggest to you people also. During examination, you need not to think without looking at the option. Read the integral, the question, and then go through the option. Option may give you a real direct hint, the form in which you have to transform so as to integrate it. Okay, so I think that's it. So that was the last question, if I am not wrong, right? Okay, so we are done with this one. Now next one will be definite integral, the mains level worksheet, bachcho.